Hello there and welcome to another A-Level Physics tutorial. Today's tutorial is on kinetic friction. Okay, let's have a look at the question. The question is, a constant force of 100 newtons is applied to a 10 kilogram box at an angle of 30 degrees above the horizontal. The coefficient of that kinetic friction is 0.15. If the box starts from rest, how far will it have travelled after 7.3 seconds? Well, let's look at the scenario. The scenario is we have a 10 kilogram mass, we have a 100 Newton force applied to that mass at 30 degrees above the horizontal, and here we have a coefficient of friction which is mu, and that's equal to 0.15. Note there's no units, it's just as it is. Okay, step 1. Let's separate the external force into its horizontal and vertical components. So here's the 100 Newton force. This is the 30 degree angle it's applied at. Here we have the horizontal component of that force, and here we have the vertical component of that force. Let's give them names. We'll give that one F sub x and this one F sub y. Okay, to solve that we just need some basic trigonometry. For this one, it's 100, obviously the hypotenuse, times the cosine of theta, which is 30. That gives us an x component of 86.6 newtons. Here we have Fy, which is equal to 100 times sine theta, which is 30 again. It gives us a y component of 15 newtons. Okay, the next step, step 2, is to draw a free body diagram to help us find the normal force and the acceleration of the system. So here we have mg in the downward force. We have Fy as a downward force. We have the normal force. We have the force in the x direction. We have the force of friction opposing that. So, in order to find that frictional force, we need to find that normal force. Now, today we're going to use 9.80 meters per second squared for gravity, and obviously due to Newton's third law, the sum of these two forces must push back to create the normal force, as it's on a solid surface and it's not on an inclined plane. So, as it says here, the box isn't accelerating upwards or downwards, so the normal force must be the sum of Fy and mg. Okay, plug some figures in there. The normal force is equal to F sub y plus m times g. That gives us a normal force of 148 newtons. Okay, now we can solve for friction. It's just about plugging some more numbers into that equation. The equation being the force of kinetic friction is equal to mu times the normal force. That is 0.15 times 148. That gives us a kinetic friction of 22.2 newtons. Now we have all these figures, we're all set to solve for acceleration in that horizontal direction. Back to our free body diagram. Okay, Fx minus the frictional force must equal the mass times the acceleration. Okay, we'll plug these in, because remember, Newton's second law clearly states that the sum of the forces equals mass times acceleration. So we have Fx minus F sub F equals the mass, which is 10 kilograms, times the acceleration. By dividing each side by 10 gives us A, which in this case is 6.44 meters per second squared. Okay, the final step. Now we need to solve for the distance travelled in 7.3 seconds. We can use one of our kinematic equations. This simply states that the distance is equal to half the acceleration times the time squared in seconds plus the initial velocity times the time in seconds. So here we plug the figures that we've already found. Obviously the initial velocity is 0, and that gives us our answer, which is the distance it would travel in 7.3 seconds is 171.6 meters. I hope you enjoyed that. I hope it was informative. If you like it, just share it, and I hope it all works for you, and keep watching it until you understand it, and I'll see you soon.